So the question that we have here is, in the worst case, the number of comparisons needed to search a singly linked list of length n for a given element, right? Imagine I have a singly linked list like this, right? A singly linked list like this, right? And let's assume I have n elements, right? It's a singly linked list, right? I have n elements. My head pointer is here, right? This is my first element, my second element, my third element, so on and so forth, n element. Now, if I want to search if a given element is present or not, what do I do? I basically start from head. I have a pointer P pointing to the head node, right? I will see suppose if I'm asked to search if element 25 is there. Now, let's assume I have this data like this, right? Suppose let's assume I have my data like this. What do? I take this search point and I now compare each of the elements in my singly linked list, the data part of it or the info part of it. I will compare with the number that I'm given. First, I'll compare with the first node. Then I'll compare with the second node. Then the third node. So on and so forth. In the worst case, I might have to search through all of the n nodes, because this number could match the last element. Could match, right? So in the worst case, the number of comparisons would be n, right? It's not log n, it's not n by 2, it's not log n minus 1. It is n comparisons that I have to make in a singly linked list to search for an item. Of course, this is the worst case, and the worst case would happen if the number I'm matching, let's assume, suppose my search number is 6, right? It would match only after I pass through. I take this pointer, search through each of these elements, and the last element is what I want, right? If the last element matches the query element that I'm given, then I have made n comparisons here. Very simple, straightforward problem.